Science Consciousness Explained.
Look out into the night sky, and you are witnessing gravity at work. It is the architect of the cosmos, the invisible hand holding planets in their orbits and shaping billion-star galaxies into massive, swirling disks. Down here on the surface, its influence seems absolute. It dictates every movement of our lives, from the predictable path of a falling apple to the way our feet stay pressed against the ground as we watch the moon. However, when scientists measure this force against the other fundamental interactions of nature, they find a startling contrast. On the scale of particles and atoms, gravity is significantly weaker than any other force in the universe. This imbalance is easy to see in a simple experiment. When you use a small household magnet to lift a paperclip, the tiny electromagnetic pull of that magnet easily overcomes the gravitational pull of the entire Earth, a rock weighing 6 septillion kilograms. The discrepancy is even more extreme at the subatomic level. Inside a single neutron, the force of gravity is over 30 orders of magnitude weaker than the nuclear forces holding the particle together. A gap this massive suggests that our standard understanding of physics is incomplete. It's a sign that we are missing a crucial piece of how gravity actually functions. If gravity has the power to govern the stars, we have to account for where that energy goes on the quantum scale. Why does so little of it seem to reach us? Physicists have proposed that gravity isn't inherently weak. Instead, they suggest its energy is actively leaking out of our observable reality. To find that missing strength, we have to look past the 3 spatial dimensions we experience every day and consider the possibility of a much larger environment. Accounting for this missing energy requires a shift in perspective, one that looks beyond our immediate surroundings to consider the geometry of the universe. Consider a world restricted to one dimension, a single line. An energy pulse moves straight ahead. Because there's nowhere to spread out, it reaches the end with its initial intensity fully intact. If we expand that line into a 2-dimensional plane, energy radiates outward in a flat, growing circle. As that circle grows, the original energy stretches across a wider circumference, thinning out by the edge. This establishes a core rule of geometry. The more dimensions a force can move into, the more it spreads out, and the weaker it becomes over a given distance. In our 3-dimensional reality, forces expand as a sphere. The energy dissipates across a volume of length, width, and depth, weakening at a predictable rate. Light, magnetism, and nuclear forces appear to be trapped within this 3D space. They stay within these 3 axes, and we measure their strength accordingly. But gravity might be the only force not confined to this 3-dimensional trap. Theories proposed in the late 90s suggest that gravity ripples into 4th, 5th, or even 6th spatial dimensions that we cannot see. If gravity bleeds into extra dimensions, its energy disperses in directions we can't perceive. Measured from our 3D slice, we see only a tiny fraction of its total strength. The rest is diluted by the higher dimensions. Gravity isn't actually weak. It is simply operating in a much larger space than we are. We can model our entire 3D universe as a thin membrane or a brane floating within a much larger, multi-dimensional space called the bulk. All matter and light are effectively glued to this 3D membrane. We cannot leave it or see past it. Gravity, however, is not stuck to the membrane. It is the only force capable of unsticking from our world and traveling through the entire volume of the bulk. This structure offers an explanation for dark matter. It suggests we aren't seeing dark matter because it isn't in our universe. We are feeling the gravitational pull of ordinary matter on a parallel brane. As gravity crosses this invisible void, we feel its echo. Because it can leave our membrane, gravity functions as a physical link between separate worlds, the only force interacting with the full volume of the bulk. A moment of wonder. This leaves a profound question about our place in the cosmos. If our gravity bleeds into these hidden dimensions, what might be bleeding in?